All right, so
Yeah.
everyone, thank you for joining us for the second lecture in part 2 of our online lecture series called The Future of AI, Social and Cultural Aspects. Today with us, we have a pleasure to host Dr. Kevin LaGrandeur. He's a professor emeritus at the New York Institute of Technology, fellow of the Institute for Ethics and Emerging Technology, co-founder of the New York Posthuman Research Group, consulting expert for the Global Institute for AI Ethics, and advisory board member of the Lifeboat Foundation. He's a member of the founding editorial boards of 2 journals, AI and Ethics, and the Journal of Posthumanism, and of the book series Critical Posthuman and Citizenship Studies. He specializes in technology and culture, ethics and education, and he has published more than 50 articles in media production, and is the author of 2 books, Artificial Slaves from 2013 and Surviving the Machine Age, co-written with sociologist James Hughes. Today's talk is titled The Implications of Digital Brain Enhancement, and he will talk about ethical issues about brain-computer interfaces and brains coupled with AI. So Kevin, the floor is yours. The screen is yours.
Thanks very much, Yelena. So I wanted to thank you, Yelena Guga, and also the Institute for Philosophy and Social Theory at the University of Belgrade for having asked me to talk today. I also want to note that this talk is a version of a recently published article, that article, I'll show you in a minute, is available for free because the journal is open access. It's in the Journal of Posthumanism. So let me share I have some slides that I'm going to share my screen now. Let's see. Okay, get my screen. So, Yelena, can you see these slides?
Yes.
Okay, just want to make sure. I'm trying to get rid of your image in the upper right-hand corner so I can see my slides. Okay, so the article is called "Are We Ready for Direct Brain Links to Machines and Each Other? A Real-World Application of Posthuman Bioethics," was published in the Journal of Posthumanism in December 2021, and the DOI is there. But if you just Google, "Are we ready for direct brain links?" you'll probably see the article. You can just click on it if you want to read it. You should hear most of it today, though. All right, so I know that most conferences or most talks focused on posthumanism, like this one, generally focus on theory. But I don't want to talk about theory today. Instead, I'm going to focus more on literature and emerging technology here in a practical and applied form. I also want to preface this talk by making it clear that I think that our emerging technology has done some amazing and good things, as my examples will show, and that I'm in favor of its continued development. However, I'm also in favor of its careful development. Right now, I don't think there's much regulation of developing technologies, and it's a little crazy as a result, like the Wild West out there. As a result, some very dangerous things are happening, as well as good things, as my examples will also show. A number of fictional accounts have been written about the possibility of enhancing the human brain through various scientific means. These fictional imaginings are now in the process of being realized via pharmaceutical, genetic, and digital means. In this presentation, I'm going to discuss 2 particularly new digital methods for brain enhancement. The first is neural lace, a term coined by Elon Musk, which is a type of brain-to-computer interface, or BCI, ultimately meant to speed up human cognition and communication. And also, I'm going to talk about a prosthetic memory that's being developed by a team at the University of Southern California. I also want to discuss how these emerging technologies are prefigured in fiction and how such fiction foreshadows some of the downsides of this kind of technology. So let's talk about neural lace first. It's a new type of brain-computer interface being developed now by Neuralink, which is a company founded by Elon Musk about 5 years ago. Neuralink is the most notable of several companies developing a new type of brain-computer interface. It's notable because of its extreme ambition. Unlike the other companies, Neuralink aims to create a wireless implement not only for helping patients recover from injury and disease, but also to enhance humans. In other words, humans that don't have anything wrong with them, to make them sort of superhuman within their cognitive abilities. He envisions having humans think as fast as computers and communicating telepathically using what's essentially an implanted wireless antenna. Neuralink's plan is to make a direct two-way digital system that's robust, compact, and wireless, and that can be easily inserted into the brain, where it'll be incorporated into the neurons of the brain. And from there, it'll be able to communicate via Wi-Fi with external computers, the World Wide Web, and so forth. Neuralink already has a prototype for this, which I'll discuss in a minute, but first, some general information about BCI. BCI is already being used therapeutically to replace the actions of limbs in paralyzed people and to help those who, like the late astrophysicist Stephen Hawking, cannot communicate physically. It's also being used to reduce seizures and in severe epileptics, resolve tremors in Parkinson's patients, and to stabilize mood disorders in psychiatric patients. But the problem is these devices that are used to do this are bulky and hardwired. You can see a picture of it here, causing difficulty for use for patients and requiring invasive surgeries and large incisions in the skull to implant them. So researchers have been trying to make these devices more compact, easier to implant, and wireless. About 4 years ago, a team at Harvard led by Charles Lieber devised a prototype for this new type of BCI, a wireless one, that seemed to offer answers to these problems. They had developed a plastic-coated micromesh of tiny wires, and I mean really tiny, because this picture that you're seeing here is the tip of a syringe with the mesh coming out of the syringe. So these are micrometers in size, the openings in the mesh. So the idea is they could insert this more easily into the brain via syringe, and this is eventually, to form an embedded wireless antenna. So they implanted this in mice, not through a syringe, but opening the mouse's head the traditional way, and found that the mesh bonded harmlessly with the brain cells within a few weeks with no side effects, and that they could subsequently use it to send and receive signals to external digital devices outside the brain. Now, one big difference between this mesh and other substances is that it's much more pliable than the traditional things that are used. And that's the big innovation for Lieber's team. It's 100 times more flexible than other implantable electronics. And this extreme pliability would ideally allow it to be rolled up, inserted into a syringe, and injected into the body rather than inserted via brain surgery. Lieber himself, at the end of his scientific article about this project, envisions the possibility that this tiny micromesh would eventually be injected via the carotid artery, by which it could then travel to the brain and bond with its cells, promising to solve the problem of invasive surgery. I mean, it would be very easy, theoretically, to put this into the carotid artery and then have it travel to the brain in a matter of seconds, and then take about 2 weeks to unfold and incorporate into the neurons. Now, the downside that nobody talks about I talked to some other scientists who do this work, and neither Musk nor Lieber pointed out the fact that this micromesh is absorbed into the brain and degenerates within about 6 months. So you'd have to put a new one in every 6 months. Anyway, Elon Musk heard about this development and was so enthralled with this mesh which he decided to call neural lace, that 2 years later in 2017, he started a new company called Neuralink, funding it with about $100 million of his own money. There are a number of other companies working on improving BCI, such as Kernel and Synchron, but Musk's company is receiving the lion's share of publicity. And a big reason for this, of course, is Musk's own notoriety, but also it's Musk's radical goals. He stated publicly that his long-term aim for such devices goes beyond current therapeutic uses of BCI. He wants to use it to enhance the human brain in order to make it competitive with AI, especially in the workplace, and perhaps eventually to allow the merging of humans with AI. Now, this is because he sees AI, as he said publicly, as an existential threat to humanity, particularly in the realm of jobs, and he sees neural lace as something that could make humans able to compete with ever more powerful AI. As he says, using neural lace in a bidirectional manner with computers, and I'm quoting him here, could make us smarter, improve our memory, help with decision-making, and eventually provide an extension of the human mind, end quote. Sidebar here on my part. Nobody's decided yet how to define what the human mind is, so he has a problem there. All right, so he also thinks that this could allow us to communicate at lightning speed with each other via form of wireless communication similar to telepathy. He wanted to start working with human subjects in clinical trials by the second quarter of 2020, but that goal has yet to happen, presumably because of the pandemic. But the company, which has about 100 employees now, probably a bit more now that we're a little later on, has just recently in January 2022 started advertising for a research director for human trials to start around now. Also, Neuralink succeeded last year, in 2021, in implanting a monkey. You see a picture of the monkey he implanted here, with a version of the BCI transmitter, and then using that transmitter to have an AI learn from the monkey's brain, the input, how to successfully play an old video game called Pong. You can see the monkey doing that here. Eventually, the monkey could play the game just by thinking about his hand movements, which is what you see in this picture, with the machine making moves based on what it had learned of the monkey's brain patterns. So a notable fictional prefiguration of BCI is Philip K. Dick's novel, Do Androids Dream of Electric Sheep, published in 1968 and known more famously by the name of its film version, Blade Runner. In the novel, as opposed to the movie, there are two notable forms of BCI. There's a machine called a mood organ and another one called the empathy box. The mood organ is a machine that characters in the story use to instantiate emotions in themselves. If they want to experience happiness, for instance, they simply dial in a particular number and the machine instills that feeling. The empathy box, on the other hand, is for a much more specific purpose. Is for the instantiation of a feeling of empathy in whoever uses it, and thus connection to fellow humans in general. It's what we would call now a virtual reality game. People in the story use it when they feel lonely and destitute, partly because there are so few people left on Earth to befriend, and partly because people have trouble being friendly because of the way society has evolved. So to use the empathy box, one grabs hold of two handles and the machine jacks the person into a virtual world by a sort of brain-machine interface. The machine puts the person into a sort of trance that causes a three-dimensional experience that in turn elicits sympathy or empathy with a vague personage in the game known as Mercer. Now, Mercer's a humanoid who's cloaked in a sort of hooded robe, and this happens when a gamer shares the sensory experience with this personage as Mercer tries to ascend a steep, rocky slope while stones rain down on him from outside of his perceptual field, presumably thrown by anonymous people who are watching him. And the person who's merging with Mercer through the empathy box feels the pelting of all these rocks, feels Mercer's pain, and thereby empathizes. So I'll come back to this in a minute, but first I want to talk about prosthetic memory. A related cognitive enhancement to neural lace has been developed by a team at the University of Southern California led by Theodore Berger. This is a prosthetic digital memory that can be implanted in the brain. It holds the possibility not only to replenish lost memories for those who have memory problems, like Alzheimer's patients, but also to artificially enhance the memories of healthy people. Berger and his team have had successes with long-term memory regeneration and generation by using implanted chips to replace damaged parts of the hippocampus in rats, monkeys, and more recently in humans. So the way this works is that a chip that you see the sort of simple demonstration of it in the lower right-hand corner. The chip contains a biomimetic program that mathematically simulates or enhances the actions that the damaged hippocampus would have made when transforming a short-term memory into a long-term one. And that's the hippocampus's, one of its main functions is to convert memories like that. That's why when people get Alzheimer's and the hippocampus degenerates, they can't embed memories. So this is aimed at therapy for dementia, for strokes, and for other causes of memory loss. And this technology has been under development by Berger and his team for about the last 10 years and is now backed by the corporation I mentioned earlier called Kernel, which is trying to commercialize it. So the upside of such technology for those suffering from memory impairment is very clear. However, there's reason to be careful about developing it because there are some indications that it could be used badly to implant false memories, for instance. In the studies with rats, Berger's team found that different rats' brains used codes common to all rats to form some types of memories. Although testing with humans and apes has been limited so far, if there is what they term a generalized memory code for those species as well, then the possibility for using this technology to implant false memories is significant. Now, the reason I say this is because what Berger did is, and I heard him talk about this, is they implanted, they took memory chips and implanted them, recorded onto them memories of a rat running a maze. And then they took the chip on which that the information was recorded and implanted it in a rat that had never run the maze, and the rat could run the maze the first time. Now, that's kind of a positive thing for the rat, but implanting somebody else's memories into another person is a way to generate memories the person never had, which has all kinds of ethical implications. So other developments with emerging technology reinforce this possibility. In 2013, MIT neuroscientists Steve Ramirez and Shu Liu were able to manipulate brain cells in a mouse to give it a false memory, that is, one about something it had never experienced. Similarly, another scientist at the University of Toronto, Sheena Jocelyn, was able to selectively eliminate a memory in a mouse by making the specific cells that the memory occupies susceptible to a certain toxin. The hope of both of these sets of scientists is that the ability to implant or delete specific memories will benefit those who've been mentally traumatized, such as those suffering from post-traumatic stress disorder or depression, or who could have their memories altered so that they don't have a strong emotional response to painful recollections. However, the negative, even dystopian possibilities of this ability to manipulate memory is also clear. Creating false memories or deleting memories represents the chance that people's privacy and personal integrity could be threatened. To illustrate this, let's look at the dangers of both this and BCI that have long appeared in fiction. I'd like to talk about that a bit, and then I'll move on to how such fiction anticipates today's real ethical concerns about these bioenhancements. So, as I said earlier, Musk's ultimate goal for using BCI is human enhancement more than healing human diseases. As he said, he ultimately hopes that implements like his neural lace will make us smarter, improve our memory, help with decision-making, and eventually provide an extension of the human mind. But what will be lost in such a transformation? What are the dangers? Does this reverse mimesis, my term for it, the incorporation of machinic elements into the human, especially into our behavioral and cognitive functions, does it threaten to dehumanize us, to make us more like machines? Well, back in the mid-60s, Philip K. Dick's science fiction novel, Blade Runner, presaged this. As I discussed earlier, their reliance on machinic interventions to aid their emotional reactions indicate that humans in the novel's future world deluded themselves in their belief that they were superior to the intelligent androids that they made because they had deeper and broader emotional capacity. The hypocrisy of this was shown in the novel by the humans' blind reliance on their machines for much of that emotional capacity. Now, I'm sure many of you can think of a number of stories that show the complications of humans becoming physically connected to or mingled with their intelligent digital tools. Let me give you a few more that I can think of off the top of my head. First, there's movies such as RoboCop, and then The Matrix, or literary fiction such as Dick's, or the novels Snow Crash, Neuromancer, and Altered Carbon. In all of these stories, humans risk being overpowered by the ingenious devices with which they choose to merge. As for technology that allows manipulation of human memories, another Philip K. Dick story leaps to mind. It's a 1966 short story called We Can Remember It For You Wholesale, made into a movie in 1990 titled Total Recall, which starred Arnold Schwarzenegger. In that movie, for those who haven't seen it, the main character, Daniel Quaid, accidentally finds out that everything he remembers, basically his whole past life, is a false memory that's been implanted in his brain by technological procedures somewhat like the ones I've been talking about. Now, without giving away too much of the story and spoiling it for you if you haven't seen it, Quaid finds that the people who've implanted these memories did it to benefit themselves. And now that he's discovered their plot, his life is in danger. The movie touches on questions of how our memories are tied to our sense of self and how their manipulation affects our sense of privacy and agency. It also implicitly comments on how readily we get seduced into using potentially invasive technology that can have significant consequences, especially if we cede to it too much of our own agency. These same issues come up with regard to the current emergent technology I've been discussing, making these stories, mostly from the 20th century, predictive of our 21st century situation. So let's look at more specifically at some of the current ethical issues with such technology. First, I'll quickly outline the ethical concerns that projects like Musk's and Berger's raise, and then I'm going to delve more deeply into the details of those ethical concerns. So the chief questions that projects such as this raise are those of safety, the distributive justice, privacy, and human autonomy and agency. Many of these questions arise with any effort to use advanced technology to provide a post-human transcendence of our species' limits. To be more specific about how this list of ethical issues, the questions here are more specifically, first, how closely is safety being monitored given the speed of these developments? And by the way, I think this is even a bigger question with recent developments with ChatGPT and other virtual chatbots that, I mean, the developments of these are incredibly fast. We already have a GPT-4 that came out yesterday or the day before. My friends have been sending me this stuff, and it's actually pretty frightening. So back to the list. Second, will the benefits of any enhancements be evenly distributed through society or just to the rich? And how will that be done? who will pay for the distribution of benefits to people other than the wealthy? Also, and not least in importance, to go back to the list, if our thoughts become easily transmittable digitally, as Musk envisions, what does that mean for the privacy of those thoughts? And furthermore, a crazy sounding question scratches at the door of possibility. If our brain is connected with the internet or other networks, wouldn't it be theoretically possible in the future to hack people's digitally connected brains? And what about the problem of coercion? As others such as Briggles in his book, A Rich Bioethics, have pointed out regarding human self-enhancement, if some people choose to use implantable BCI, for instance, to make themselves more competitive with machines, then they also become more competitive with other humans for jobs, as well as for other pursuits. Consequently, others will feel compelled or coerced to get the implants too, whether or not they really want them. Or they might feel that way. It's just a concern. Ultimately, personal privacy and autonomy is a big issue because the basis of neural lace, as conceived and tested by Lieber's team at Harvard, was that the Wi-Fi antenna implanted in a subject's brain would have technology connected to it to allow two-way translation from brain waves to code and from computer code to brain waves. This would eventually crack the digital brain barrier as part of the process of providing the sort of telepathy that Musk hopes for. Such technology as he envisions entails making a subject's brain data directly accessible for collection by outside entities, such as corporations and governments, in addition to medical groups. And this would threaten individual privacy and autonomy. Now, this might all sound far-fetched, but this is already happening in certain places like China. China is monitoring data from some employees' brains by forcing them to wear caps outfitted with sensors while they work. The caps look like the ones in this picture here. These sensor array caps can scan their brainwaves for emotional disturbances and send that data to their bosses. This procedure is taking place for three types of Chinese workers: telecommunications factory workers, high-speed train drivers, and military workers. Hangzhou Zhongheng Electric is one company that uses this arrangement. According to information provided by themselves, workers on their production lines all wear caps with sensors that monitor their brainwaves, and then management feeds that data into algorithms that allow AI to recommend changes in the workflow, such as adjusting the pace of production and redesigning those workflows. So the company claims that, among other things, they can use this process to, and I'm quoting them here, to increase the overall efficiency of the workers by manipulating the frequency and length of break times to reduce mental stress, end quote. So the Chinese government is the major funder of the research into this area, but Chinese managers and scientists also promote this technology, asserting that it can improve safety. As one professor of brain science and cognitive psychology at the Chinese university, Ningbo University, said, quote, "A highly emotional employee in a key post could affect an entire production line, jeopardizing his or her own safety as well as that of others. Some jobs require high concentration and there's no room for a mistake," end quote. The Chinese also use this kind of rationale to justify the monitoring of high-speed train drivers. Deya, a technology company in Shanghai, said its brain monitoring devices were worn regularly by train drivers working on the Beijing-Shanghai high-speed train line. The devices are worn under the driver's cap and can monitor an array of things, including fatigue, attention loss, and so forth. If the system detects these things, it sounds an alarm in the cabin to wake the engineer up. Now, despite proclamations of increasing safety and efficiency, other proclamations show that a major reason for this technology for the Chinese is just increasing profit. Hangzhou Electric, for instance, bragged that, quote, "it has boosted company profits by 2 billion yuan, about $315 million, since it was rolled out in 2014. So This kind of monitoring seems in reality to be a violation of cognitive freedom for the sake of profits as much as safety or anything else. There are also clear problems here, not only with user privacy and autonomy, but also with informed consent. For instance, with respect to consent, it's unclear whether there's really effective communication to the users of the complex ways these devices work and proper framing of how users' information is used. Perhaps most important to consider is the question of human autonomy and agency. An example of how technology such as Musk's is already used as therapy illustrates this. BCI, as you see in this picture here, is sort of a representation of how BCI is being used as a therapeutic device for the brain. It's already being used as a form of next generation deep brain stimulation to treat mood and emotional disorders such as obsessive compulsive disorder and depression. The use of computer brain BCI like Neuralinks would be for the purpose of regulating the therapeutic stimulation to the brain to enhance its consistency. Because diseases such as depression vary in intensity and frequency, it would be much more effective if an AI algorithm could monitor and then adjust to the brain accordingly, as is done now with implantable defibrillators for the heart. The problem is that directly modulating the brain raises questions, again, of autonomy and agency as well as privacy. In terms of privacy, one group of BCI researchers themselves note, quote, a system that employs BCI-like technology to decode a patient's emotional state, it comes much closer to mind reading than existing motor BCIs that move arms and legs. The internal data from such a system could be damaging if compromised. Regarding autonomy and personal agency, if an AI is controlling the brain's moods and the reactions a person has toward her environment, then both patients and physicians worry, is it the person or the AI being expressed at any given moment? Some neuroscientists working on this type of BCI point out, quote, if an AI controller is added, one has effectively constructed a device that autonomously determines what the patient may or may not feel, end quote. Patients in those researchers' study also expressed the same concerns. Some patients who've been treated for depression using this advanced BCI deep brain stimulation started losing their sense of self. One said, quote, there are parts of this where you just wonder how much is you anymore, and you wonder kind of how much of this is my thought pattern. How would I deal with this if I didn't have the stimulation system? You kind of feel artificial, end quote. So how does all this relate back to Musk and Neuralace? Well, as two of the foregoing examples of BCI show, there are possible benefits, public benefits to brain implants and sensors, like increased safety for public transit in China and therapeutic psychological benefits for those who suffer from depression or OCD. But these are countered by some serious possible downsides. As opposed to these innovations, which have specific and relatively limited uses, Musk's idea of implantable wireless antennae into the brain for a general purpose of raising our cognitive speed, memory capacity, and intelligence by direct connection to digital devices has much less specific situational benefits. Yet it has all of the dangers of all the other examples of BCI I just mentioned, and maybe more. Consider this. Who would pay for everyone to get these implants so as to encourage distributive justice and, telepathy for everybody? Well, Walter Veit, in his research, has tried to answer this by suggesting that employers would have a natural desire to pay for enhancements for their employees, and that this would resolve uneven availability to people and concentration of benefits to the rich. But I think this is unlikely. After all, only certain large, wealthy corporations have the deep pockets to provide novel bioenhancements, and they would likely be very selective to whom they provide them, given the expense. In their chapter of the book, Enhancing Human Capacities, Nick Bostrom and Rebecca Roach suggest using government subsidies to promote fair distribution. Sounds good, but we already have a huge public resistance to government subsidies, at least in America. And it's also growing even in places like Switzerland and in Finland. For example, the latter country, Finland's experiment with universal basic income was cut short for this reason. People resisted public subsidies. And in Switzerland, public resistance to universal basic income's implementation ultimately prevented it altogether. Also, with regard to potential enhancement that might result, there's a question of efficacy for Musk's wireless BCI. Increased intelligence doesn't necessarily resolve bad behavior, unhappiness, and emotional problems, as any psychologist would probably tell you. Instead, current research suggests that by some measures, it's personality traits like conscientiousness that make the difference for self-actualization and social success. Indeed, as one can discover by working with academics, as I do, and many of us do, a person can be very smart and still be a neurotic, unhappy mess. And the impact upon privacy of the telepathic communication that Musk envisions with neural lace is unlikely to improve some unhappy pathologies like paranoia. So to finish my talk, I want to talk a little bit about what I think is needed, which is regulation, and it needs to be international, somewhat like the nuclear regulatory agencies now. At the very least, the more practical solution, given all the foregoing examples, would be some sort of regulation for highly transformative next generation BCI devices like neural lace. There are already regulatory models to consider. One might be a type of broad statement of ethical standards for BCI development that scientists and researchers who develop these tools would agree to in order to try to ensure that everyone was operating along the same ethical lines. The recently published Montreal Declaration regarding responsible development of AI is an example of this sort of agreement for emerging technology. It was originally drafted and promoted by Yoshua Bengio a few years ago and others at a recent meeting of academics at the University of Montreal. And it's now posted online as a document, a sort of manifesto, for the signature of anybody who's concerned about the responsible development of emerging technology, no matter who you are. I signed it, and you can too if you want to by just Googling it. Perhaps it could be something like this, could be adapted specifically for BCI. Another model is provided by Alan Buchanan's idea of having a global institute for justice in innovation, or GIGI. He discusses this in his book, Beyond Humanity. This type of institute would license companies to distribute bioenhancing innovations and make sure via various means that innovations are used and distributed fairly. And a final model promoted by Oxford philosopher Nick Bostrom in a landmark article he wrote called The Vulnerable World Hypothesis, which is famous enough that the article is covered on Wikipedia. The idea would be to regulate and license access to key materials for making dangerous innovations rather than by regulating their output. This, he thinks, would have the possible advantage of discouraging bad operators. They wouldn't be able to get a hold of materials to make dangerous things. So I want to end this whole talk here by making a final plea that whatever we choose, we have to have some regulation. I mean, overregulation, of course, slows down innovation. But if you don't have any, disaster occurs, and especially if you do it post hoc. There's much possible good in our smart technology, but we need to be careful to keep these applications humane, equitable, and safe. Thank you very much for sharing this time with me.
Thank you so much, Kevin, for this insightful lecture. I myself wrote down a couple of questions, but I will open the Q&A session, giving words to the participants here, and then I will jump in with some of the questions. So if anyone has a question, please just unmute and speak, or you can raise your hand. Okay, Jelena, I see Jelena Novakovic.
Thank you for this amazing lecture. I just want your opinion. Do you think regulations are really something that will happen, or is just wishful thinking? What is your opinion?
My opinion on what again? I'm sorry, I didn't catch.
Regulations, are they going to happen? Or just the evolution of technology is going without any regulation whatsoever?
Yeah, well, I think without regulation, we're going to have disasters. I mean, I didn't talk about ChatGPT in this talk because that's a whole nother issue. But there are people here I know who've probably used it. I used it already just to play with it. And it's pretty frightening. As an academic, especially as a humanist, I assign papers. I don't know how many of you here assign papers to your students, but talk about cheating probabilities. Now, the early ChatGPT has not been that convincing. I mean, luckily, if you're an expert, you can tell when somebody's used an AI because it's very smoothly written, but it's kind of gibberish when it comes to the content. But that technology is going to get better and better. And look at the danger of that. I mean, that's very apparent. Misinformation is already able to be spread via social media very rapidly and very dangerously. So anyway, if we don't start regulating this stuff, and we're going to have a lot of problems as society. And by the way, I'm not the only one to say this. The people who invented ChatGPT say the same thing. The CEO of OpenAI said he agrees with me on this. I mean, not me, but he agrees with this idea. Same with Elon Musk, same with Bill Gates. So, you know, we're in good company if we hope for regulation. The key thing is the political will to do it. I don't know about that. I'm speaking from an American point of view, but if you follow American politics, regulation is constantly under fire here in the United States. I don't know what it's like, say, in Serbia, if it's wide open, you know, or not. Well, maybe you can tell me something about that. What's the attitude toward regulation in Serbia and in other parts of Europe?
Hello, it was very inspiring to hear your lecture. One of the best lectures I've heard on these topics. You presented it very well, and it was very clear. So it is amazing video to share. My name is Ljubisha. I'm also coordinating the lab with Jelena, and I just wanted to say that this is the topic of regulations that we deal in Serbia, but I think we're not so important markets because we are very small. And Jelena and myself took part in AI ethics committee of the Serbian government. And the main thing that we made a contribution was labeling recommender systems as high-risk AI systems, because in our view, we also signed the Belgrade Digital Freedom Pledge, and in our view, recommender systems are very dangerous for humanity and their future, and for narrowing our minds, and they have to be public good in terms that they are regulated on international level. And I'm very glad that I've heard that from you too, that some kind of international UN regulation would be good, or just recommendation for member states of the UN. So this is our idea, and we're going to go with this to promote the pledge and this idea that recommender systems become a common good or public good, I would say. And on the other side, digital identity should be also recognized as human right.
That's
so
really great.
This is from our side.
Yeah, that's really great.
Much.
I'd also like to add to that it's very encouraging that big money, and in America, big money is important. Big money is already behind this. I know people, there's a whole unit at the Carnegie Foundation that's focused just on worldwide dangers of technology and how to stop it. It's being run by a woman from Norway who used to work at the UN. And so that's encouraging too. I'm sorry, there's another hand up.
I see two hands. I would just like to jump in because I want to kind of continue on this line of thought. When we talk about regulations, as I noticed, but also I read in Stefan Lawrence Zorberg's book, We Have Always Been Cyborgs, that the US has a system of not really regulating it because it's all kind of about the corporate interests. So it's kind of being pushed in that direction. And then on the other side, we have China, which is all like government regulated, but in a sense of surveilling basically their citizens and through introducing, for example, social credit, which is kind of right directly from that Black Mirror episode, but it's actually happening in reality. And then in the middle, you have Europe, which went like, whoa, stop. We stop everything. So Europe is actually working on regulations, not only of AI, but also other emerging technologies. But in Stefan's opinion, and I remember this really strongly from his book, is that Europe should open up, should give up on privacy in terms of their digital data. Otherwise, if we don't do that, we will be lacking a lot and kind of being behind the rest of the world, that is the US and China. So what's your quick take on that?
Well, that's an old argument. Much as I like Stefan, I disagree strongly with that. If you just open everything up, it continues to be the Wild West. And, you know, I use that American metaphor because the American West in its early days, especially as it's depicted in movies, is chaotic and people are shooting guns everywhere. And, you know, and I think that's what it's like right now with digital technology as well. Yes, there's a concern about falling behind. I understand that. But the same argument has been made for nuclear weapons. And I don't see, for instance, Serbia racing to get a nuclear bomb, or, you know, or where Stefan works in Italy, they're not so concerned about racing, you know, to get a nuclear weapon either. So, I mean, you know, I think that his opinion is a little radical. If he's here, he might want to argue with me about that. I try not to be radical in I hope I didn't sound radical in my opinions. I think there needs to be regulation, but it has to be careful so it doesn't stifle innovation.
Okay, thank you. So first hand up was Vladimir Bratic. Vladimir, please.
Yeah, thanks for the lecture. I have a question about, after studying this Neuralink, and let's take out the paralysis application, but the communicational aspect of it, this bidirectional neural lace. To what degree do you think this is just a head fake and a smart PR head fake on Musk? And considering what we've learned in the last year by the purchase of Twitter and some serious scrutiny that he's received as a result of that, in which people kind of looked deeper and realized that this is more, that Twitter purchase is more in like his control of his plans to build a hyperloop or sell flamethrowers. To what degree do you think this sort of attempt for telepathic communication is something that is rather sexy to be picked up to build his PR? Because what we've seen him do and what he excels as is this ability to become a hype man for the things that he really is interested in. And to what degree is this just a PR attempt to secure the cult of a frontier digital man for his true profit-driven agencies, which are Starlink and Tesla?
Yeah.
Do you think this can be compared more to a flamethrower or the real enterprise towards telepathic communication?
Yeah, I think that I'm laughing because I think Elon Musk is sort of a hand grenade with a bad haircut. You know, he just likes throwing things out there to make waves. But I think I would never underestimate his seriousness about anything he says, because people underestimated him before when he said he was going to make rockets and send them out into space, and he did it, and I laughed when he said he was going to buy Twitter. I thought that's preposterous. He couldn't possibly raise that much money, even though he's a billionaire, blah, blah, blah. And then he did it. So, I never know which of his crazy statements is going to come true or not. So I choose to take him seriously about his intentions for Neuralink. He spent a huge amount of money on it, and he's putting more in. But I'm not sure if his technological capabilities will be up to completely making a mesh that you can inject in the carotid artery, and that's that simple. Because other experts in in neurology that I consulted said it's going to be very difficult to do that. And what they've only managed to do so far is make a better implant machine, which is like a sewing machine that implants the devices in the head, and it's still invasive. So who knows? But I think telepathy is a little ridiculous, and who would want that anyway?
Would you have to dig all the way to Broca and Wernicke's part of the brain to get to the language processing and generation? Because so far you just put a chip in a front of in sort of the surface level brain level. You just shaved a little bit of hair and dug through the skull.
Yeah, one of the things neuroscientists, they talk about, the neuroscientists I've talked about this with, talk about the importance of location in the brain of this neural mesh. You can't just drop it, anywhere. Like you said, Broca's fissure, a center for speech, is a very specific region of I think it's the temporal lobe, if I remember right. So yeah, I mean, it's not so easy. And when scientists work with rats and human beings with these wired devices, they have to implant into the proper part of the brain. Unfortunately, they have to make holes that are like this big as well.
Okay, thank you. Mark, we had Anna before you, so can you give your question? So after Anna,
hello. Do you see me? Do you hear me? Okay.
Yeah.
Yeah. Okay. Great. First, thank you very much for a very interesting talk. And my question is, as I have some legal background, my question is from the practical legal point of view. Okay, let's say we have some regulation. How do you imagine it works? I mean, well, is it going to be embedded thing like 3 laws or for robots, Asimov's way, or is it going to be something else, or collective? So solution, how would we want that regulation to work actually, if it works? Thank you.
Yeah, that's a good question. I'm not a lawyer, and my specialty isn't regulation, but the best people I know in the United States that are doing this is Arizona State University. Their law school has a special section of lawyers who do nothing but, who study nothing but regulation of emerging technology. Gary Marchand is the head of one of the most important lawyers in that area. So he has some interesting articles about it. But basically what most of them are saying, from what I understand, is, and what I'm proposing, is a regulatory body, like the Nuclear Regulatory Agency, but for emerging technology that's digital. I've studied embedding laws into robots and AI. Most computer science experts who've tried to do that have failed miserably, because you're trying to basically build a conscience for a robot. And what that means is, human consciences determining right and wrong are very complex things that mix emotion with cognition. And it's not just logic. There's one particular guy in the United States who works at Georgia Tech who tried to theorize how to build an artificial conscience for robots for the military so that they wouldn't shoot the wrong people. And he could only go with a few philosophical models like Kantian deontology, which is based on sense of duty, and also utilitarianism, because both of those systems are sort of if-then, it's constructed by if-then statements that are easy to translate into computer code. But he still couldn't get it to work because it only uses logic. And humans don't use just logic to determine right and wrong. So anyway, that's why I don't think it would work to build conscience into an AI.
Thank you.
You're welcome.
Thank you. Mark?
Yes. Can you hear me okay?
Yeah, hi, Stu. I know this guy. He's a
Okay,
troublemaker.
Thank you so much for this talk and this, whoever organized this. I'm not really familiar with how it came to be, but it's really encouraging. I'm a psychotherapist and have been communicating with Kevin for a little bit specifically about all of this. And so he brings it together just beautifully, I think. And I think the essential aspect is the ethical aspect. The technological aspect is on its own, and it's a freight train unleashed. So I wanted to bring attention to the politics and the economics and see what Kevin's comment might be. In America, we have all these regulatory agencies, and they're, like Kevin is saying, they're just constantly embattled, both politically and economically. And someone like Musk, who, he's a self-proclaimed autistic person. So by definition, he has, let's just say, lacking social sensitivities. So, and his visions are going to have huge blind spots in the way of humanity in general. So anyway, my question is around if you take a parallel like green politics and economics and the ethical considerations of saving our climate, which is completely out of control. And so I'm wondering, we have regulatory agencies, the Food and Drug Administration, HIPAA, all these entities. So I'm wondering if you've thought of, because it's going to have to come from money, the economics. There's not going to be ethical considerations without money. And I was just drawing a parallel with that, with the green ethics and all that. So say something about that.
Yeah, so I agree with you wholeheartedly. This is going to be difficult. And it's going to have to be backed by money in the United States, because in the United States, money is everything, just about. And like I said, I'm heartened and encouraged by the fact that money is lining up behind the effort to regulate. Now, Musk, you're right, he's not only self-identified as autistic and so has some social problems, but he also identifies as a libertarian politically, as do most Silicon Valley CEOs. They want no part of regulation. They don't want government involved in anything. They just want everybody else to go away and leave them alone in their bunkers. So there has to be a huge force opposite that. And that's stacking up. You have people like George Soros, for instance, who has a lot of money and he supports causes like climate change resistance. And also, like I said before, the Carnegie Endowment has already defined a unit and formed a unit of people who are doing exactly what I'm encouraging people to do, which is to study the potential negative effects of emerging technology and how to regulate it. And the group at Arizona State University, by the way, at the law school there, that's another group. And they're backed by not big money, but they're getting grants in addition to state money and federal money. So this is going to be a big political battle, Stu. I think it's going to be tough. The forces are lined up already on the side of resisting regulation, but there are also people lining up that are pro-regulatory. In fact, the European Union, as Yelena said, is one of those units. And that's a big chunk of the world that's more strict. I mean, look what they've done with social media. They've really put the kibosh on Microsoft, which isn't social media, but they're very careful about people's privacy compared to the United States or China, for that matter. So it's going to be a problem, but I think we can do it.
Thank you. We also have questions in the chat, and at the same.
You muted yourself, Yelena.
Sorry, that was a thank you to Mark. We have one point of information in the chat that Maya Vujovic is using her assistant as one of the participants here, which joined the meeting via an integration with Zoom, and it records and transcribes the meeting using AI and takes snapshots and slides. But I don't see any, it's just a point of information, not a question. And we have another question by Mikhail Bukhtoyarov in the chat. Do you see it, Kevin? Or
I'm reading it, yeah. I'll read it out loud if that's okay. If humanity comes to the point where it becomes a seamless web of technologically connected human minds or several collective agents, will individual personality be possible? What could be the conditions for individual human beings to remain evolutionarily competitive? Well, I think those are two separate questions. As for whether individual personality would be possible if we were all linked, say, telepathically, I think that's a question more for somebody like Mark Stewart, who just spoke. He's a psychologist. I'm not. And I, off the top of my head, don't know how to answer that. So I'll defer. Maybe Mark could talk up to that point in a minute. But as far as the second question, what could be the conditions for individuals, human beings, to remain evolutionarily competitive? Well, I think that depends on what the evolutionary pressures are on human beings. I think I kind of agree with Musk that if we allow AI to rampantly proliferate, we're going to be in existential crisis. And I agree with him on that. How to resolve that? His plan is twofold: to create more AI that's even more powerful, that's implanted in us. And second, if that fails, to move to Mars on a colony that he starts with SpaceX. And he said both of these things as plan A and plan B. I would say we need to stick around Earth and try to fix what we've screwed up on Earth first. If we have smaller evolutionary pressures from, say, climate change, I think AI could be very helpful with it, used properly. So like I said before, I'm in favor of AI, just its judicious use, not rampant use for whatever. Maybe, would it be okay to have Mark answer the question about collective identity?
I'd love to hear Mark answer this question. Yeah.
Stu, are you still there? He might have left.
No, he's not here.
Yeah, I think he left,
Yeah.
Left the room. But I mean, the little I know about psychology is that we're already sort of a collective. We're evolved from pack animals like wolves. So we already have a sort of collective identity and an individual identity. And they're kind of, they shift depending on the situation. Think of a mob with mob violence. In those situations, psychologists have long said people lose their individual agency and identity and tend to just be moved by the mob and its whatever it's doing. So, you know, there are instances in which we lose our individual identity anyway. We go to a football game and go crazy, you know, during the match. And even if we don't become soccer hooligans, you know, we sort of move with the crowd in some ways. So I don't know. First of all, I think it's a long stretch to think that we're going to actually be able to communicate telepathically with AI. Maybe down maybe 50 years from now or 100 years from now. But I just don't see that kind of AI being cheap enough and available enough to implant in everybody's brain.
Is it necessary to implant it in everybody's brain? And are we giving too much credit to AI, especially when it comes to AI controllers that you mentioned that are already used in patients with depression or PTSD? AI isn't that perfect because behind AI, there's still human agency of human labor that actually constructed AI, and AI is trained on human generated data. So it's not flawless, it's not seamless. And I think that we as academics, but even more so general public, have this idea of AI as perfection. So would we even want that, and for what purpose? I mean, don't get me wrong, I'm very enthusiastic about emerging technologies, but at the same time critical. So and I always ask the question, what's it for? What's the purpose?
Yeah, I agree. I feel the same way. I mean, AI, if used properly, which I keep saying, it can be very powerful. I mean, right now, AI is only really good at very specific things, very specific. Like, for instance, there was an article on the front page of the New York Times about 3 days ago about AI that can detect breast cancer through various means, chiefly imaging, X-rays, MRIs, that kind of thing. And it's better than doctors at doing it. Great. That means that women may not die so much from breast cancer. And it trains itself on sets of data, but they're very specific data, they're images, and it learns what a tumor looks like. And it just has a much better field record of accomplishment. Same with playing chess or playing the game Go, because with something that specific that for which there are very isolated, maybe a lot, but isolated possibilities. Like in chess, you may have, for any one move, you may have 256 possibilities, but there's still 256, not infinite. And so the AI can generate and run through those possibilities much better than a human brain. So anyway, I think there are, as far as, the miraculous stuff, it's possible for telepathy if we can implant a Wi-Fi in your brain, and if the computer coding, two-way coding, is good enough to rapidly translate what you get over the web into brain signals. Right now, they're doing pretty well with that kind of thing. So maybe artificial general intelligence, that's like humans? I don't think so. And the most computer scientists I talk to say that's hundreds of years off, if at all. So it all depends. And also, like you said, it depends on which data we choose. When you choose medical images, that's a pretty finite set of data.
Yeah.
Even if you scrape everything off the web like ChatGPT does, it's still ultimately finite, although very large set of data. But like you said, the problem with that data is there's a lot of false data in there. That's why I can tell when some student uses it, because they put something that's absolutely wrong in the result. Like, for instance, I was trained as an English professor on English literature, and somebody generated a paragraph for me about Mark Twain, the famous American writer, and said, first of all, that his most famous literary work was The Jumping Frog of Calaveras County. That's a very minor short story. And then said it was about a frog that could speak. But the title contradicts that, The Jumping Frog, not the talking frog. So anyway, it's there's a lot of flaws in the data there.
Yeah. Okay, thank you very much. I see that you're losing your your voice, and thank you so much for sticking through the whole discussion. Do we have any more questions? No? Okay, so thank you so much, Kevin, again.
Can I do the last one, please?
Yeah. Okay.
I wanted to ask you, what do you think about AI or not AI? Do you think that technology is emerging somehow as a new religion, not in terms of being religion per se, but being religion in terms that people really want to pursue it, and that, you know, no other way is acceptable for humankind except developing these technologies and really believing in technology as Christianity before or something like that. Do you agree with that statement? So this is my last question. Thank you.
Yeah, no, I think it's crazy. I know a lot of transhumanists because there are a lot of them in the Institute for Ethics and Emerging Technology that I'm a fellow of. So I've been to a lot of meetings where there's actually an Eastern European religion. I think it's Russian, actually, in origin. And I'm forgetting the name of it, but they're about 30 to 40 years old, and they believe, like you said, that the religion should center around human potential as enhanced by technology. In other words, it's a transhumanist religion. I don't have that much optimism about technology. And I also don't have that much optimism about our alteration of ourselves with technology as most transhumanists do. Natasha Vita-Moore and Max Moore are good examples. They're in my organization. I don't agree with them. I don't think you should freeze your head, chop it off and freeze it, hoping that you'll be able to revive yourself to 300 years from now in full capacity. Just, there's really no scientific basis for any of that.
Yeah, and especially lately that neuroscientific research and cognitive science show more and more proof that you can't actually rely on cognitivist actually paradigm, because more and more what is called 4E cognition, embedded, embodied, and active and extended cognition is actually more in the real world. And this is what's going on, that you can't basically separate your brain from your body. And just before the talk, I ran into a title that keeping your muscles healthy keeps your brain healthy. So this is something that we can't separate the two. So that's why I see their starting premise as false, unfounded, basically.
Yes, right. And Catherine Hale said the same thing in her book, How We Became Posthuman.
Yeah.
She and most neuroscientists I've heard or talked to also believe that the brain and the mind, brain, and body are all integrated without
and the environment.
one. Right. So just putting away your meat puppet into a frozen locker for 200 years isn't going to do much good.
Thank you. Thank you so much. Thank you, everyone, for joining us. Our next lecture is by Andreas Kaminski. It's going to be on the 6th of April. I added the link for the announcement for the remaining 2 lectures in this part 2. And just to give you a heads up, we are preparing also the 3rd and final part, which will of this lecture series, which will take place in September, from September to November. So thank you all, and see you in April. Thanks again, Kevin.
My pleasure.